All right, so this lecture is going to be all about measurement. We'll talk about types of measures and then get into reliability and validity. Okay, so there's different types of measures. One is self-report. That's usually, in the form of surveys or, some type of measure where participants are giving their answers to questions. There's also observational measures, which is when we're watching or observing people's behaviors. And then physiological measures, which includes taking, vitals, biological data like blood pressure, heart rate, brain scans. And so, in terms of which type is best, that all depends on how you operationalize your variable. It can also depend on other factors such as who your participants are or what your research question is. For example, if you're doing research with children and anxiety, young children can't necessarily report to you how anxious they feel, like on a self-report survey. So you might have to observe behaviors that indicate anxiety or record things like their heart rate to get at that, to answer your research question. Operationalizing variable. So here's workshop number 4. Go ahead and complete this. You can press pause here to take some time to complete that before moving on. I wanted to just give just a little example of a measure and how measures come together and thinking about, the validities associated with them. So here, this headline says, college students think they're so special. The claim here is that the study finds alarming rise in narcissism, self-centeredness in Generation Me. So looking at what type of claim this is, here we're looking at a frequency claim since we're talking about a rise in narcissism. The variable here is narcissism. If we wanted to evaluate how the variable is measured, which validity would we be concerned about? And then the answer to that would be construct validity. So remember, construct validity is about how valid our measure is. To assess construct validity, what types of questions would we ask? Here, if we're looking at our measure, we're going to ask, is the measure reliable and is the measure valid? So I wanted to just give you a quick fun example about how a narcissism might be operationalized. So here's an example of a real narcissistic personality inventory, the MPI. And I just wanted to give you a feel for how variables can be measured using self-report. So we call this an inventory. It can be called a scale or a measurement or a survey, all pretty much meaning the same thing. You have multiple questions addressing different aspects of your variable because you can't really capture everything in one question. You can't just ask people, are you narcissistic, yes or no? So in this example, there are 16 questions on this inventory. Here are questions 1 through 8. And then here are questions 9 through 16. So researchers would have people complete the whole inventory, all 16 questions, and then take an average to get your score. And based on that score, they can determine your level of narcissism. Okay, now let's talk about reliability and validity of measures. Again, because this is how we assess the construct validity. So starting with reliability, we'll cover 3 questions. What is reliability? What are the 3 types of reliability, and how do we evaluate reliability? So what is reliability? Reliability is all about consistency. If we're using a scale to measure the same object or the same construct and there's no changes to that construct, I should get a same reading every time. So if I, for example, had one of those food scales that you keep in your kitchen, if I weigh some fruit and then I take the fruit off of the scale and weigh it again, assuming that I haven't changed that fruit, I should get the same weight. If not, then my scale is not reliable. It's not consistent. So 3 types of reliability we'll talk about are test, retest reliability, internal reliability, and inter-rater reliability. Test, retest reliability is all about consistency over time. People should be getting consistent scores every time they take a measure. So this applies to all of the types of measures that we talked about. And it's most relevant when we're studying things that should be stable. For example, your personality, intelligence, religiosity. For example, if I measure intelligence one day in a group of participants and I had those same participants come back a couple of weeks later, they should have the same or similar scores because your intelligence shouldn't have changed within a week. If not, then you don't have a good test, retest reliability. Internal reliability is all about consistency regardless of phrasing. I want to just note here that this is not the same as internal validity. Those are two separate things. Make sure that you know the difference. So internal reliability applies to self-report measures or, like surveys. And the idea is that if you have multiple questions on a survey measuring the same construct, a participant should be answering consistently to those questions. Otherwise, you know that they're probably not good questions and they're not assessing what you think you're assessing, at least not reliably. So for example, if I was measuring some personality, these are two different questions on the same survey. So I like to be the center of attention and I am uncomfortable when all eyes are on me. These questions are phrased differently, but they're asking about introversion and extroversion. Both of them are. So if someone answers strongly agree to this first question, they should be answering that they strongly disagree with the second one. That would be consistent with their personality. Okay, next we have inter-rater reliability. So this is about consistency between raters, and this is most applicable when we're talking about observational measures. Often when you're doing an observational study, you want to have more than one person doing the observation so that it's more objective. And so when you have multiple people doing observations, you have to see whether their observations are consistent. That's how you know if they're looking at the same thing. So for example, if I was looking at smiles and recording, if I was looking at happiness and recording how many times people smile, observer 1 would record how many times a participant smiles, and observer 2 would also record the same thing. And then I would probably want to look at if those two things are correlated. So looking at scatter plots can help us to evaluate reliability, specifically when we talk about test-retest reliability and also inter-rater reliability. I want to see if these two things are correlated. If people's scores at test 1 are correlated with their second time taking the same measure, or if I'm using two raters, are the two raters' observations correlated? So I'm going to give you an example for how we can use scatter plots for inter-rater reliability. Let's say we had researchers looking at this question: do male giant panda cubs play more roughly than female giant panda cubs? So let's say we have two observers watching the same video of male and female panda playing, and they're recording their observations of how many times each panda bites. And so that's how they've operationalized rough playing is through a number of bites. And so in this table below here, we have the two observers' observations of the female panda and the male panda. And so in order to make this scatter plot, first I'm going to create ordered pairs. I'm going to assign a variable to each observer. So observer 1 is going to be X, observer 2 is going to be Y. And ordered pairs are these coordinates I have. So I'm going to create my ordered pairs here, as you see on the screen. And then I'm going to want to plot this data. So X is my horizontal axis and Y is my vertical axis. So plotting the points first for the female panda, my coordinates for that are 2 and 3. So if I find 2 on the x-axis and 3 on the y-axis, my point would be there. And then the male panda, my x is 5 and my y is 4. So that point is going to be there. After I do this, I'm going to insert a line of fit, which is going to represent the correlation. And so this line lets me know that there's a positive correlation between these two observations. That's going to indicate agreement. So according to this, I have good inter-rater reliability. In other words, I can be confident that the measure that the two observers used is consistent and therefore reliable. So here's a review of what we just did. You can pause to take notes or come back to this slide when you are doing your workshop number 4. So here's workshop number 4. If you're completing this in Microsoft Word document that's downloaded from iCollege, you don't need to produce a graph on the actual computer on the document. If you're doing this by hand, you can go ahead and scan, your graph in, and that's fine. All right, moving on to validity, we're going to cover 3 questions here. What is measurement validity? How do we assess measurement validity? And then we're also going to talk about the relationship between reliability and validity. So what is measurement validity? Measurement validity is all about whether your measurement tool measures what it's supposed to measure. We need to assess measurement validity because often we're measuring abstract concepts like happiness, stress, self esteem. We come up with these measures and these observations and these questions that are really just approximations of those constructs. So, measurement validity is all about how do we know we're measuring what we intend to measure? How do we know we're not measuring something else? There's 4 different types of validity we'll talk about: face validity, content validity, criterion validity, and then convergent and discriminant validity. So face validity and content validity refer to how your measurement looks, and these are subjective. So face validity is your measurement plausible? Does it look like it measures what you think it does? And you can check this by checking in with people or consulting with experts about whether or not these questions or your protocol or whatever your measure is fits your construct. And then there's content validity, which is referring to does your measure capture all parts of your variable or of your construct? Does it represent all aspects of the variable? So for example, if I ask you 1 plus 1 and you can answer that correctly, that gives me an idea that you understand basic addition principles, but it doesn't give me an idea of your overall mathematical knowledge. So it's not good, it doesn't have good content validity if I'm trying to assess your mathematical knowledge. Then there's criterion validity. So the question here is, does your measure correlate with key outcomes? The measure should be related to other variables that it can predict or that it makes sense for this variable to be associated with. For example, a sales ability test score should be correlated with actual sales, and it is. So that's what this graph depicts here. So if you have knowledge about sales ability, that should be correlated with your ability to actually make sales. IQ, if I were to measure IQ, that doesn't have good criterion validity for the outcome of sales because those things are not necessarily correlated. So now for convergent and discriminant validity. Discriminant validity can also be referred as divergent validity if you want to, because they are contrasting in 2 sides of the same coin. So we're looking at if the patterns of variables make sense. So with convergent validity, we're looking at if measures of the same variables are correlated. They should be correlated. And measures of different variables should not be so highly correlated. So oftentimes we have more than one measure or more than one way of measuring the same variable. But if they're measuring the same thing, then those different measures should be correlated with each other. For example, let's say I have 2 different surveys that are both examining depression. Those 2 things should be correlated. If I plotted them on a correlation chart, I should see a positive correlation. Similarly, if I have 2 different surveys or 2 different measures that are assessing different variables, then those 2 measures should not be highly correlated. Now, there might be some overlap, but you should be able to distinguish between the 2 constructs. So here's an example. Here I have 2 different measures, the BDI, which is the Beck Depression Inventory, and the CESD, which is also another measure of depression. So both of them measure depression, and it looks like they are correlated with one another. So I see the points like going in a positive slope. And then on this chart, I have the BDI as well on the x-axis, and then I have a measure of physical health. Those 2 things should not necessarily be correlated. So, and I see that in this scatter plot here. So these are not correlated, so I can be sure that they are measuring different things, that they're measuring what they're supposed to measure. All right, so I have the question here of what is the relationship between reliability and validity. You want to make sure that you know the difference between reliability and validity and also how they are related. So question here is, can a measure be reliable but not valid? Absolutely. And here's what that would look like. Reliability is just that your measure consistently is hitting the same place at every time. but that doesn't mean that it's actually hitting the target that it's supposed to hit. So reliability is necessary for validity, but it's not sufficient. In other words, just because a measure is reliable doesn't mean it's valid. Of course, the goal is to have both validity and reliability. That means you're hitting the target where it should hit every time. Another question is, can a measure be valid but not reliable? And the answer to that is no. Even if a measure is not even valid, it can't be reliable. Again, reliability is required for validity. All right, that's it for today. Tried to keep it short this week since we had a test. As always, let me know if you have any questions. Take care.